Hello. In today's lesson, we're going to learn how to write an infinite decimal periodic fraction as a fractional number. What is the purpose? Is it necessary to do this? The point is that if we have the following expression, 0.7 in a period plus 0.73 hundredths in the period. The point is that in order to solve this example, you first have to convert periodic decimal fractions into regular fractions. Why? Because if you start calculating this example like this, you're going to get an inaccurate answer, and math likes exact numbers. So first we need to write down the infinite periodic decimal fraction in the form of an ordinary fractional number and then perform the action. How do we do that? Let's write down the number 0.7 in a period in order to write this number in fractional form. What do I have to do? If I try to write this number as an infinite periodic decimal, the result is that we get 0 integers and the number 7 will be repeated an infinite number of times. Of course, when writing down such a number, I can round the number, but it will be an approximate value, and we need to be exact. To do this, we need to know the following rule. In order to write down an infinite decimal as a fractional number, we need to write down the digits that are written in the period in the numerator. And then in this case, the number 7 is written in the period. And in the denominator, write down in the denominator. So we have to write down the number of digits in the period. We have 1 digit in the period. So I'm going to write down exactly 19. Once again, in order to write this number as a fractional number, I have to write down period. The period of the decimal in the numerator. And in the denominator, write only the 9s. How many digits are in the period? In our case, there's 1 digit in the period. So the fraction 0.7 in the period is the number 7 9s. So in our example, I go back and I write down 7 9ths plus. And now the next number is 0.73 hundredths. Now what we've agreed on is that we're going to write in the numerator, of the numbers in the numerator, that are in the period, which is 73. And then in the denominator, we write as many 9s as there are digits in the period. There are 2 digits in the period, so I write 2 9s. And the result is a fraction like this. Let's go back to our example and write down 7 9s plus 73 99s. And when we see the example, as the sum of 2 fractional numbers, we can do the addition. To do this, we need to bring to a common denominator, and the common denominator is 99. Because 99, we can divide by 99, that's 1. And 99 can be divided by 9, that's 11. The result is 77 plus 73. And 77 plus 73 is 150 99ths. If it's possible, you can divide the numerator and denominator by the same number. 150 and 99 can be divided by 3. 150 divided by 3 is 50, and 99 divided by 3 is 33. Now 50 33, let's write down 50 33rds. That's 1.17 33rds. And as you can see, we found the meaning of this expression if the numbers were infinite decimal periodic fractional numbers. But when you and I converted an infinite decimal periodic fraction into an instantaneous fraction and used our technique, we noticed that the period is immediately after the decimal point. If we look at the following example and convert the number 2.1/10 and 7/100 into a period, we won't be able to use this rule right away. Why? Because before the period, we have one digit that doesn't repeat. So what I need to do is move the comma one digit to the right, but let's not be in a hurry, and let's write it down in a different form. Let's write the number 2 separately because it's two integers, 0 whole. 1/10 and 7 in a period, we'll write it separately. Why? Because we're not going to touch the two integers, and we're going to work with periodic fractions. What should we do in this case? If our problem is that in the previous examples we had a decimal point right after the decimal point, then in this case we need to move that comma one character to the right. How can we accomplish this? If I write 0.1 and 7/100 in the period, I can move that comma. But what do I have to do that? To do that, I have to multiply by 10. Then the comma will move to the right, which means I'll write 0.1/10 and 7/100 in the period times 10. But if I multiply by 10, divide by 10, and then the numerator will be 1.7. 7/10 in the period divided by 10. 1.7 in the period. Let's work with this number. What do we get? We'll keep 1 point. And the 7 in the period is 7/9. That's 1.7/9 divided by 10. And then 1.7/9 is 16/9. 1 times 9 is 9. 9 plus 7 is 16. 16/9 divided by 10 or multiplied by 1. 1/10. The result is 16/9. And then that's the number I'm going to carry over into our example. 2 plus 16/90. And 2 plus 16/90 is 2.16/90. By using the algorithm that I showed you today, we can write down any periodic decimal fraction as an ordinary fraction. But please pay attention that we're talking about an infinite periodic decimal. We'll solve some more examples in the next lesson, and that's all for today. Goodbye. See you again.